Welcome to this video number 34, which is about estimating single equation and why OLS estimator will be biased in such a case. Monte Carlo simulation of OLS, Monte Carlo simulation of OLS, 2SLS using Excel, simultaneous equation, simultaneity bias, and I shall share this Excel spreadsheet source with you. You can download exactly the same sheet and you can carry out all the things which I will demonstrate here. So the purpose of this video is to show you that if you are going to estimate single equation model when there is simultaneity, when there is endogeneity, why there will be bias. That bias we are going to study in practice by using data which we already know, and that's I am going to demonstrate you in here that we have basically two equations. Usually we study demand and supply equation in the demand and supply equations, but here I am discussing a slightly different example. Enforcement spending is equal to gamma naught plus gamma 1 crime rate. Increasing crime rate will lead to enforcement in spending increase. That is, more the crime rate, there will be more investment in policing and in other equipment. And but what's the issue? Issue is that if you will invest more in enforcement spending, that means there will be better enforcement there, which means it will lead to lower crime rate. That will lead to endogeneity issue. So crime rate in return depends on enforcement spending, and Gini is coefficient of inequality. As I have downloaded this from Bretto and Bretto Introduction to Econometrics, I shall give you these 10 pages MS Word notes and this Excel spreadsheet source. Gini coefficient is purely exogenous variable. Higher the income inequality, more the crime rate. So when we replace this crime rate here, when we replace here crime rate, we have basically crime rate. When I replace it here, we get this equation enforcement spending. And when we replace enforcement spending here, we get this crime rate. So you see here error terms are mixed up. So it means crime rate is a function of enforcement spending, and it means crime rate and these two are uncorrelated, are correlated, which leads to simultaneity bias. So how we are going to estimate this and how we are going to carry out Monte Carlo simulation and all that, let's be with me. We have this data and we have this gamma naught, gamma 1, standard error and all that. So we have all this, and now you see we are basically generating standard errors here. This is basically based on one standard deviation and standard error related here, epsilon enforcement spending, spending that will be here. And you see this is the same equation which we have calculated here, this one. Enforcement spending is equal to gamma naught over gamma 1 and all that. And if you look here, so here in the formula bar, you will see the same thing as we have here, gamma 1, beta 1 and all that. So we have used different values of gamma 1, beta 1 and all that. Now we are going to regress. These are 20 values of enforcement spending and crime rate, and these are simulated values based on these parametric values. We have estimated linear estimation. Leanest is the function and we have calculated this function. Okay, we cannot change one cell when we have array formula. This is the standard error. This is R square, and this is degree of freedom to 18, 20 minus 1. It's sum of squares of residuals. Now, if you look at this model, here you have basically minus 0.005, whereas actually this value is 0.02. Means if you increase, there will be an increase in crime rate, there will be spending, 2% more spending in enforcement. And but here you have minus 0.005, which is biased. What I'm going to do here in here, I am going to show that it is very there is significant bias here. We are going to basically simulate this number 1000 times, and we'll have a simulated distribution of this one. So this is minus 0.005 is for one time. If I do this second time, press F9. Again, press F9, 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 F9. So you see every time it's not going towards 0.02. It's biased. That's that we are going to generate here. I am going to do it in front of you. Add-ins, basically the book, the source I'll show you. From there you can download Monte Carlo simulation add-ins, and if you go to Monte Carlo simulation add-ins, you will have here Monte Carlo simulation add-ins. So you can use that Monte Carlo simulation to generate this data, to simulate this data, and this will show you that this OLS estimator is biased. Here it is minus 0.008 and standard deviation is 0.03. So you see actual coefficient is 0.02, which should be here. Whereas what we are getting most of the times, that is minus 0.008. So it is highly biased. So it is highly biased because we are getting results around here, whereas 0.02 is here. So therefore these results are highly biased. Sorry for a little pause. I try to use Monte Carlo simulation add-ins. So here I am going to basically run this Monte Carlo simulation add-ins, and you will see that this will be in front of you, and you have minus 0.08 and 0.0075, and this is highly biased, whereas actual results are 0.02, which is here. But your standard error, but your most of the times your this is the frequency. So maximum number of times your results are around minus 0.01, minus 0.02, and 0, and between minus 0.02. So these are biased results. So let's move forward. This is how you can see. And now we come to that why this bias, what happens. So basically, if you see, the actual relationship should look like this positive upward sloping curve, which is red line between crime rate and enforcement spending. But when you regress, it is negatively, this dark red line, it is negatively sloping. Why is it so? Because you are basically ignoring the simultaneity bias, because your enforcement crime rate is basically function of enforcement spending shocks as well. So if you trace any single observation, you have here this Gini coefficient is basically sorted out. If you use 19th observation and you trace these one observation, if I press F9, look here. So 19 is moving like this way. And if you trace all this, trace one observation, look here what happens. I'm now, instead of 19th observation, I'm going to trace out second observation. Okay, we need to basically give the observation number. I am going to write here 2. So you see, ah, wow, dancing, but dancing in opposite direction. If you take 2 observations, you see, again, I am going to take first and 19th observation. What happens? Again, press F9. These are also dancing, but opposite direction. So trace 2 observations. Look here, number 2 and number 4. Okay. So trace 2 observations, number 1 and number 8. Okay. You see 18 and 19. If you press F9, if you trace the whole data, you see these strips, pink strips are opposite direction, are moving in opposite direction. So why this bias? Let's see. Let's click on this Y bias. If you make this one 0, these strips will become vertical. Why? Because you don't have any uncertainty in enforcement error shock. So there will be no bias. Or if you place this beta 1 equal to 0, again there will be no bias, and you can see here. So why bias? Click on this. I shall share this Excel spreadsheet. I am saying it again and again. Enjoy it and understand this. So you see here, if you change these values, if you change this scroll bar, if you change this standard error and all that, you will get basically different results. And so this is how we are, this is why we are getting biasness here. So we can see that the level of bias, that basically depends on the uh, standard error, the error term in enforcement spending, or beta 1. If beta 1 is 0, it means crime rate is not, enforcement is not basically affecting crime rate. So this you can see vertical bias and all that. So let's go back to our main file, and here you see all you have this one. For example, if I place it 0, so it means this will lead to, okay, press F9 for for anything. Okay, if this is 0, so this will lead to, there should be no bias. Okay, slightly still vertical strips, we'll see. Okay, let's go. So you see what is going on, that if you are estimating it by one equation, the original one, with increasing crime rate, you should have more spending in enforcement. But here, if you are estimating it by a single equation, it will lead to opposite results. It will show you negative results. It will lead to bias in gamma. It will lead to bias in gamma. So again, you see we have changed these values of standard error of epsilon is enforcement and all that. That's why these results have no change slightly. So if you, again, we are back to the original one. Now, what to do? That's why we need to estimate two-stage least square. We use instrumental variable regression, and that I'm going to demonstrate. I have already uploaded very comprehensive videos, video number 29 to 33 on instrumental variable regression, and I hope this will help you in understanding the concept. So in this case, first of all, we are going to regress crime rate on Gini, Gini value. That is this one. From this, we'll get predicted value of Gini. So you see here we have regressed G22 on D22. G22 was your crime and D22 were your Gini values. You can go back and see this screen. And we have here predicted values. Okay, here we have predicted values. And what are these predicted values? Look here. So these two, this is your intercept, blue one, this pink is your slope coefficient, and our predicted value D22 is basically Gini coefficient. So these are your predicted values. So instead of using crime rate values, we are going to use CR hat value, X hat value, P hat value, so that it is now that part of CR which is free of this the epsilon enforcement spending error. So now you will have, again, at second stage we are going to regress enforcement spending on these predicted values of crime rate instead of regressing on crime rate. And you see this coefficient is very close now to 0.02. If I if I repeat it, F9. So you see, it's no not, it may not be very biased. And if I do it simulation, again the same way, I am going to simulate this cell, and let's proceed. Okay, you see, it is 0.022. So you got the point that why we get biased results when there is endogeneity issue. You can explore this simulation. This is basically 2SLS. This simulation which we have done now, this is basically 2SLS simulation. The previous one which we have done, that was OLS. OLS results are biased when there is endogeneity. You can explore these things. I shall share. Okay, from where you can get this, go to basically, wait a minute, I'll share you link here. I shall share the link below this video as well. I shall share the notes basically for this lecture as well. Thank you for watching. Take care.